saving for retirement, saving to buy a home, saving money for a child's college fund. All of these topics involve a long-term savings plan in which you could make a series of regular payments over many years to accumulate the money you need. An annuity is an interest-bearing account into which we make a series of payments of the same size. If one payment is made at the end of every compounding period, the annuity is called an ordinary annuity. The future value of an annuity is the amount in the account including the interest after all the payments. The formula for the future value of an ordinary annuity is A equals your payment times, and in the parentheses we have a fraction. Upstairs we have 1 plus r over n to the nth power minus 1, and then in the denominator we have a r over n. A is the future value, PYMT is your periodic payment, R is your annual interest rate, T is the number of years, and N is the number of compounding periods per year. Let's look at an example. Sue decides to invest in an ordinary annuity as part of her retirement plan. If she deposits $175 at the end of each month into an ordinary annuity, which earns 8% interest compounded monthly, how much money will she have after 35 years? I'm also kind of curious as to how much money Sue actually invested into this annuity. Well, first let's find out how much money she'll have after the 35 years. Okay. The amount at the end of the investment, the future value, is equal to payment times 1 plus r over n to the nt minus 1 all over r over n. Well, her payment is $175. Here's your annual interest rate. We're compounding monthly. N is 12. And we're doing this for 35 years, or Sue is. So let's substitute these values into the formula. A equals her $175 monthly payment times, parentheses, 1 plus 0.08 over 12 raised to the 12 times 35 minus 1 all over 0.08 over 12. Now we need to very carefully put this into our calculator. And what I'm going to do is I'm going to put the entire numerator inside the parentheses in my calculator, hit enter, and then divide by what's in my denominator and hit enter, and then finally to multiply by the monthly payment, which is $175. So we're going to have parentheses 1 plus 0.08 divided by 12, close parentheses, raised to the parentheses 12 times 35, close parentheses, minus 1, enter, and then divide by parentheses, all these parentheses are very critical, 0.08 divided by 12, close parentheses, hit enter, and then multiply that by her monthly payment, which is $175 a month, enter. So at the end of these 35 years, the amount in the account that Sue will have will be $401,429.43. So if she makes a $175 a month payment into an ordinary annuity, which is getting 8% interest compounded monthly, and she does this for 35 years, Sue will have over $400,000 at the end of this investment. Now the follow-up question was, how much money did Sue actually invest in this annuity? Well, Sue made payments of $175 a month, 12 times a year, for 35 years. So this is her out-of-pocket. $175 a month times 12 months times 35 years. Her out-of-pocket expense is $73,450. $500, and she'll have over $400,000. That's the power of periodic investments for a long period of time and earning compound interest. Let's look at another example. Use the formula for the future value of an ordinary annuity to calculate A, the future value. If we have monthly payments of $150, the annual rate is 7.5%, and the number of monthly payments is 516. So this time we're not told how many years a person's making monthly payments. We're told the total number of payments. Well, I'm going to figure out how many years this is because the way we've been talking and using the formula, T has been our time in years. So 516 monthly payments divided by 12 months means that this person is going to be investing in this annuity for 43 years. Now let's see how much money they'll have at the end of these 43 years. The amount at the end of the investment is the payment. And inside parentheses 1 plus R over N to the NT minus 1 all over R over N. We know our payment. We know what R is. We know what T is. And we're making monthly payments in is 12. So A is equal to 150 times 1 plus 0.075 over 12 raised to the 12 times 43 minus 1 all over 0.075 over 12. And again, I need to very carefully put this in my calculator. The big issue here is correctly using my calculator. So I'm going to put the numerator inside first. Parentheses 1 plus 0.075 divided by 12, close parentheses, raise the parentheses, 12 times 43, close parentheses, minus 1, enter. Now we'll divide by parentheses 0.075 divided by 12, close parentheses, enter, and multiply that result by the $150 a month payment. So at the end of this investment, the end of this annuity, the person will have $573,657.29.